class, we have seen the concept of NAND realization, right? So, and also we have seen the another realization, that is NOR realization. Means when you are going to have a terminology called sum of products expression, or an expression called product of sums expression, we can able to easily implement it using NAND gates. If it is product of sums, we can able to implement it using NOR gates. Why? If it is in the form of sum of the products, we can able to easily implement with the help of AND/OR gates. AND/OR gate, right? If it is in the form of product of sums, we can able to easily implement with the help of OR AND gates, right? For example, if you take AB plus CD is a kind of a Boolean function or a Boolean expression, right? So it is in the form of sum of the products, right? So if you take AB implementation, it will look like this, AB, and if you take CD, it requires one AND gate. And if you are going to perform OR operation, these two outputs should be attached to one more OR gate. One more OR gate. Finally, you are going to get AB plus CD as the output, right? For example, if you would like to implement it with help of NAND relation, what you will do simply, you can simply bubble up output of AND gate, bubble up, and inputs of OR gate is going to be bubble up, right? So finally, your input OR gate is going to bubble up with bubbles. So this gate will be indirectly acting as NAND gate. So this input will be given to like this, and this input will be given to like this, so that it is the implementation of NAND realization. Okay, means if you are able to observe here, how many levels are there, ma? These first two AND gates are from level 1, and the output gate is at level 2. This is what we can call it as two-level synthesis. Two-level synthesis, meaning that whatever the circuit that you are trying to construct, that circuit is having two levels. When if you are going to follow the approach of sum of the products approach or product of the sum approach, you will get two-level synthesis. Means, for example, I am trying to take only a plus b into c plus d, right? So first expression you are going to get with help of OR gate. Second expression you are going to get with help of OR gate. Finally, you are going to perform AND operation, right? So this first level we call it as level 1, and second level we call it as level 2. You are going to get the result, right? Meaning that simply, if it is in the sum of the products or in the product of the sums, you are going to get two levels. You are going to get two levels. That is what you can call it as two-level synthesis mechanism, right? Sometimes if you are able to observe the XR implementation, how many NAND gates are required? 4 NAND gates are required, right? Basically, if it is like XY bar plus YX bar, how many levels are required here? How many levels are required? Try to observe here. So assume that this is X and Y bar. My output will be like this, and YX bar output will be again an OR gate. Again, it's a kind of two-level gate. But if you are going to implement with the help of NAND, how many how many NAND gates are required? 4 NAND gates are required, right? If it is in the form of NAND realization, you require 4 NAND gates. 4 NAND gates, right? So at that situation, how many levels are there? See, if you are going to observe the example, right? If you take this one, up to here we call it as level 1, and this level we call it as level 2, and this level we call it as level 3, right? Meaning that if you observe any circuit, if the circuit is having more than two levels, I can call it as multi-level synthesis circuit. Meaning that it is going to have more than 3 levels. So at what stage you are going to get more than 2 levels? If the expression is either not in the form of sum of products or not in the form of product of sums, then you may get as multi-level expression or multi-level synthesis, right? For example, try to take ABCD is one kind of expression, right? So if you would like to implement it with help of two input AND gate, how many levels are required? I think 3 levels, right? AB is an input. This output you need to connect it to C. Again you are going to get one output as ABC. Again this output you need to connect it to one more gate. This is what I can call it as ABCD, right? This is a simple example what you mean by multi-level synthesis, right? In multi-level synthesis you are going to get more than 2 levels. I can call it as multi-level synthesis. For example, if you try to take this example, f function f equal to a into b plus cd or c bar d, right? If you are able to try to construct the circuit, you are going to get more than 2 levels. Why? First I am going to take a as input directly, then I need to construct b, it is okay. Then I need to take cd. For this cd there should be an AND gate required. This AND gate is going to perform OR operation over b. You are going to get next level. Right? For this next level, what you require? You require to have AND gate, meaning that level 3 is there. Right? Now this output you need to perform with again C bar D. This will be like a complementation. Again it will be like a normal operation, and these two will be the OR operation, right? So if you are able to observe, this is level 1, level 2, level 3 and level 4, right? So this is what I can call it as multi-level synthesis, right? So when there is a chance to get multi-level synthesis, if the expression is not in the form of sum of the products or not in the form of product of the sums, definitely you are going to get multi-level synthesis. In all the remaining cases you are going to get only 2-level synthesis. Okay, fine. If the result, whatever the operation that you are trying to perform on a particular circuit, you are going to give certain inputs, it is going to produce certain output, right? If this output is going to generate only single operation term, I can call it as degenerative function. Meaning that whatever the output that circuit is going to produce, if it is going to produce single operation term, I can call it as degenerative function. So what is the meaning of this one? Meaning that whatever the term that I am going to get as output, that term I can able to simply implement with help of only one gate. For example, assume that my output is ABCD. Can I able to implement with help of four input AND gate? Yes or no? So simply I can take 4 inputs A, B, C, D, that I can call it as degenerative function. On the other hand, another kind of function is there, non-degenerative function. What is the meaning of this one? It is going to produce, meaning that this circuit is going to produce output in the form of sum of the products or in the form of product of the sums. If I am saying that it is in sum of the products or in the product of sums, what is the meaning of this one? It contains more than one term, right? If I am trying to say that a plus b into b plus c, this is my result will get. This is what product of the sums. Or ab plus cd, this is the example for some of the products, right? So this expression I can call it as non-degenerative function, where if it is going to produce only single operation, I can call it as degenerative function, right? At what situations you may get degenerative functions? Can you able to tell what are the chances to get some of the products or product of the sums expressions? Can you give some examples? Like for example, try to take under circuit. Under circuit, is it going to produce some of the products? Yes. So the output which is generated by under combination is always going to be a non-degenerate function. Similarly, R and is a, again it is going to produce product of the sums. I can call it as non-degenerate function, right? Is there any combination where it is going to produce only single operation? No, right? For example, try to take a simple example. I am trying to take AB and CD is on two inputs, and I am trying to produce an output with AND gate again. What is the output you are going to get? ABCD, right? Again, this is a kind of a term which is having a single operation. Single operation meaning that completely AND operation, right? Then I can call it as a degenerate function. Degenerate function, right? What is the combination for to get degenerate functions? AND. So AND is one possibility, is one of the possibility to get a degenerate function. Similarly, there are certain other possibilities are there that I am going to write. AND NAND gate functionality. AND NAND gate combination also is going to produce degenerate function number. RR, similarly, RR is going to produce single operation or not? For example, try to take R, finally again it is going to produce an R operation, right? A, B, C, D as input, A plus B plus C plus D, right? Meaning that A plus B plus C plus D, again they are going to implement with help of only single operation. Single 4 input OR gate I can able to. So that is what I can call it as degenerate function. So RR is also one possibility. Similarly, OR NOR. See, if we are going to have main gates and OR NAND NOR, how many combinations are you going to get? 2 power 4 combinations you are going to get, right? 2 power 4 combinations means total 16 combinations you are going to get. Out of the 16 combinations, 8 combinations are meant for degenerate functions and 8 combinations are meant for non-degenerate functions. Non-degenerate, right? What are these 8 combinations means? I am trying to write here. Another one is NAND or NAND NOR, NOR and NAND. These are the 8 combinations that if you are going to use in our circuit, it is going to produce a degenerate function. Degenerate function, right? If you are going to take all the remaining combinations, they are going to produce non-degenerate functions, right? So I am going to write. So one is AND OR, another one is OR AND, another one is AND NOR combination, or NAND combination is possibility is there. NAND NAND combination, NAND and combination, NOR NOR combination, NOR OR combination. Okay, so these are the other 8 combinations which are meant for to define non-degenerate function. Sir, do we need to remember all these means? No. Just when they are going to ask you, try to implement some simple circuit. If that simple circuit is going to produce degenerate or generative, based on that you can tell the answer. That's it. No need to by heart anything, right? Okay, fine. So try, for example, I am trying to take simple thing. Uh, for example, AB as input for OR gate. What is the output you are going to get? A plus B. A plus B. And I am going to take one more combination, which is, what is this one? NOR. NOR, right? So what is the expression you are going to get? A plus B plus C whole bar. A plus B plus C whole bar. What is the output you are going to get? A plus B bar dot C bar. Finally, we are going to do A bar dot B bar dot C bar, right? So meaning that it is going to result into one single operation or not, right? Then I can call this terminology also or and or is also comes under degenerative function. Degenerative function. Okay, fine. So what are things that we are trying to discuss, right? We are going to have a Boolean function. We are going to have a Boolean function. With the help of this Boolean function, I can able to simply construct one circuit only. I can able to simply construct one circuit. It is okay for me. So okay. So if I am going to give certain expression for you, like for example, AB C bar D bar, AB C bar D, A B bar C bar D, A B C D, A B bar C D, A B C D bar, A B bar C D bar, right? So for this, can you able to construct a circuit? Can you able to construct a circuit? Yes. Finally, it is in what kind of operation? Sum of the products. When it is in sum of the products, I can able to construct a circuit in and or combination easily, right? When I able to construct and or combination easily, I can able to implement with the help of NAND realization also. NAND realization also, right? So here, this is my circuit. This is my Boolean function. If you would like to ask you to implement a circuit, what you will do? You are going to take this many number of AND gates. Am I right or not? For example, I am asking you to construct uh, a 4 input AND gate. A 4 input AND gate. Then what you are going to take simply, you are going to take one AND gate which is taking 4 inputs, and for this expression one AND gate, like this. How many AND gates are required now? Total 3, 3, 6, 7 AND gates are required, which is going to take 4 inputs. 4 input. So for example, if they are asking for 2 input AND gate, then what will happen? It will require more number of gates are run. Yes, fine. Is there any solution to reduce this expression? Yes or no? We already discussed, right? We can able to simply solve this expression so that you are going to get minimize this expression. So that for that minimized expression, if I am going to construct circuit, the output of this function is equivalent to the minimized function also, right? So try to minimize the function. So try to check here from these two terms, from these two terminologies. I am going to take out ABC bar as out. If I am going to take ABC bar as out, I am going to get D bar plus D, D bar plus D, right? And I am going to leave this as this AB bar C bar D. From these two, can I able to take anything as a common? Yes, ACD. You are going to get B plus B bar. From these two, can I take anything as common? ACD bar. If I take ACD bar, you are going to get B plus B bar. B plus B bar. Finally, you can write, right? So D plus D bar means what? 1. So you will get the expression ABC bar, AB bar C bar, sorry, AB bar C bar D, ACD, ACD bar. This is our next expression what you are going to get, right? Once you got from these two common things, can I take the AC as common? Yes, right? So ABC bar, AB bar, C bar D. From these two terminology, I am going to take out the common as D plus D bar. So D plus D bar is equal to again 1, right? So if I rewrite the expression ABC bar, AB bar, C bar D plus AC, plus AC, right? Now try to think. I am going to take out these two terms. These two terms. Can I take common as A? Yes, right? So if I take the common as A, you are going to get B C bar plus C plus A B bar C bar D, right? What is this expression? Can I apply what kind of principle? Distributive can I apply? Distributive. A plus BC means A plus B into A plus C, right? If I am going to do that, C plus C bar into C plus B, C plus B. I can write A B bar C bar D, right? So now C plus C bar means what? 1. So now I am going to again apply distributive property. Then what you are going to get? AC plus AB plus AB bar C bar D. C bar D, right? Now can I able to like simplify this expression again? So I will try to rewrite here. AC plus AB plus AB bar C bar D. Is there any chance to reduce this expression? What we can do? Can I take the common as A among these two? Can I take the common? Yes. If I take the common, AC will be as is. If I take the common of A, see, you may get question here. Sir, why can't you take the common for all? Yes, we can take, but we may stop there itself, right? I don't want to stop there itself. I want to minimize the maximum extent. So that's why I'm trying to do this particular procedure, right? If I take the common as A, B plus B bar C bar D, right? What is this expression again? Again distributive property. A plus BC means, right? What you can do? Again you are going to get AC plus A of, what is the result you can able to get from this one? B plus C bar D. B plus B bar into B plus C bar D. So can I write like B plus C bar D directly? Yes. Try to again multiply AC plus AB plus AC bar D. AC bar D, right? Now again try to do with the combination of these two. I hope you understood now, right? If I take the common of these two as A, C plus C bar D plus AB. Now what you are going to get? A into C plus D plus AB, which I can rewrite as AB plus AC plus AD. Is there any way to now reduce this expression? If at all, you can able to take the common as A and that's it. We can stop the expression, right? So this is the final minimized expression for this one, right? Basically, if you would like to implement this expression, you require 7 4 input AND gates and some more OR gates also, right? But if you take this expression, how many AND gates are required? 2 input AND gates are 3 and 2 input OR gates, I think 3. Am I right? So why you are getting 3? A, B, C, D. You are going to get one result. For this, one OR gate is required, and AD is you are going to get. For this, you need to have one more OR gate, and finally, you are going to get the result. Okay. So two input OR gates are required also. Two. Right? This is what, right? So compared to this one, is it the best efficient one or not? Yes. Right. That efficiency can be in terms of area, or it in terms of power dissipation, right? Meaning that if you are going to construct a circuit, here how many levels you are going to get? 2 levels. Here also you are going to get 2 levels, but the way that is transferring the data is going to be more in the large expression. Am I right? And one more thing, when you are trying to solve this expression, is it difficult to solve this expression or not? It is very difficult to solve this expression, right? So as I know, this is my result, so I am going to work on this way. But as a like you cannot able to get this result at a single stretch. Am I right? That is the problem. So at this situation, result may vary also. Result may vary means circuit design will compulsory vary, right? Okay. Next, try to take one more expression. For example, A bar B C bar plus A bar B bar C bar plus A B bar C bar plus A B bar A bar B C plus A B C plus A B bar C. Okay. So can we try to implement this expression using AND OR gates? Yes, we can implement. But you know, as it is a large expression, you are going to get very large circuit, right? So instead of getting the large circuit, we can able to simplify the expression so that the same kind of outcome we can able to get with the help of very less small circuit. So what you can do here, try to reduce this expression. What you can observe between these two terminologies? Can I take the a bar c bar as a common? A bar c bar common. And if I take a bar c bar common, you are going to get b plus b bar. B plus b bar, right? Now try to do some kind of common terminologies. So can I do here the common terminologies as BC? Yes. If I take BC as a common, you are going to get a bar plus a. From these two, can I take anything as common? A B bar. You are going to get again C bar plus C bar plus C, right? So if you are going to solve it, you are going to get A bar C bar plus BC plus AB bar, right? Now try to tell, is there any way to solve this expression? No. I think we may simplify it, right? If you are able to observe, if you are able to observe, is there any chance? Is there any formulas can be able to apply? I think if you would like to apply, it should be in the form of at least distributive form, A plus BC form. Is there any A plus BC form? No, every combination contains two literals, right? If it is every combination contains two literals, it may not be possible to again simplify the data maximum extent, right? So this is my final non-redundant expression. Non-redundant expression. What is the meaning of non-redundant expression? I cannot able to remove any kind of literals from the expression. That is what I can call it as non-redundant expression. Okay, fine. Now for this Boolean expression, can I able to implement circuit? Yes, we can able to implement. Okay, so try to observe one more way. One more way. I am going to write the same operation. I am trying to take out the two common terminals like a bar c bar. I am going to get b plus b bar plus. I am going to take out bc as common. BC as common, then I am going to get a plus a bar or a bar plus a. Is it okay for everyone? Yes. And what are the remaining two terminologies? A, B bar, C bar and A, B bar, C. I didn't done anything for these two. Okay, fine. Now try to solve it. You are going to get A bar C bar plus BC plus A B bar C bar plus A B bar C. B bar C, right? Now try to do with these two and try to do with these two, right? If we try to do with these two, what will happen? What is the common terminals you can able to observe? C bar, C bar, right? If I try to take out the common C bar, you are going to get A bar plus AB bar. If I try to take out the common as C, I think C, you are going to get B plus B bar A. What is this one? Again distributive property, right? So C bar into, so I think you, if you are going to distribute it, you are going to get A bar plus B bar plus C into A plus B. I hope you understood, right? If you are trying to distribute over the terminologies, A bar plus A into A bar plus B bar. So A plus A bar is 1, so you will get like this. Okay. Now try to like again apply the distributive property. You are going to get A bar C bar plus B bar C bar plus AC plus BC plus BC, right? Now is there any chance to decrease this expression? What we can do? Can we take? What we can take? Okay, so I can take C. Even I can take C. It is again converted into other form, right? See, my aim is to make as every expression should be implemented form. So it should be in and/or form or it in or and form, right? If I am going to take out the common as C, you are going to get C into A plus B, which is again expression as combination of both sum of the products as well as product of the sums, right? So I can say that this is my again one more non-redundant expression. One more non-redundant expression, or I can call it as irredundant expression also. Irredundant expression meaning that I couldn't able to reduce further, right? So is there any solution further? If it is any there, you can tell me, no problem, right? Finally, I would like to conclude here is, if you are going to solve it in one way, you are going to get one solution. If you are going to get in solve in one way, you are going to get some solution. If it is going to solve by someone, they may get some kind of another expression, some like k. Am I right or not? Finally, the result is same. At any cost, result is same. But how the cost of the implementation? What about the area of the digital board? What about the cost of the implementation? If you are going to consider all these design parameters, the expression which is having very minimum number of terms, which is going to occupy less area, less cost, right? So you have to find out a solution to that, right? So as a as a designer, you have to solve like this, right? But at certain situation you may get this as a result, certain situation you may get this as a result, certain situation you may get this as a result, but it should not happen, right? Whether you are going to follow any kind of approach, you should have to get only one simple result, right? For that reason, we are moving for another kind of procedure, that is K-maps. So from this time, you don't need to by heart any formulas, anything. You can just simply go through some procedure, right? Meaning that if you are going to have any kind of a Boolean function, this Boolean function I can able to like minimize with the help of normal Boolean theorems. Normal Boolean theorems. So far, what are things that we have seen? But what is the drawback here? Based on the applicability, based upon that time, you are going to get certain kind of expressions. Simple thing is, you may get, so trying to solve the expression may be very complex. This is one problem. Or you may get more than one expression sometimes. More than one expression sometimes, right? And that expression is also not the minimum expression. Not the minimal expression. So it may yield to wrong answer. It may yield to wrong answer means what? It is going to take high cost and more size, right? That is the meaning of that, right? So to overcome this drawback, we are moving for another concept called K-maps. K-maps. So what is the purpose of K-maps? Which is used for to minimize Boolean expression. Which is used for to minimize the Boolean expression. That's it. Okay, fine. So how this K-maps is going to work? So actually, when you are going to have an expression, try to think, if an expression is like this, basically I can able to represent a Boolean expression in the form of an expression first, in the form of a function, right? For example, I am trying to take xy bar plus x bar y. Is it a Boolean function? The same thing, can I able to represent in the form of canonical function? Yes or no? So in canonical function, what is the meaning of this one? I need to compulsory define in the form of standard sum of the products, or in the form of standard product of the sums. Product of sum, right? This is another way. Another way is I can go with the Venn diagrams. The another important way is I can go with the truth tables. Right? So if I would like to implement this expression, what is the truth table for this expression? If I am going to have the inputs x and y, your result should be, this is what? XR y. XRY means what? Right? 0 0 as input, 0 1 as input, 1 0 as input, 1 1 as input. Output will be, when both are same, result is 0, and all the remaining cases output will be 1, right? So meaning that the same expression I am going to represent in this also, right? So meaning that I can write this one as output as x bar y, this one as x y bar. These two are same. If you try to write this expression in the form of standard sum of the products, is there an extra terminals you are going to get? No, it is already in standard sum of the products, right? Meaning that, how can you say that it is in standard sum of the products? If you take any term, that term should have n variables, right? As I have taken two variables are in some either complement form or in non-complement form, so I can call it as standard sum of the form, right? The same thing, if you would like to define the like Venn diagram, we can able to implement also, right? Fine. So the advantage of K-map is, K-map which is used for to minimize the Boolean expression. And how can we minimize this Boolean expression means, when you are going to have the data in the form of truth tables, right? Meaning that it is diagrammatic representation of, I can write one other terminology, diagrammatic representation of a truth table. It is diagrammatic representation of truth table, right? In truth table, what are the values you are going to have? You are going to have Boolean values either 0 or 1, right? So if I am going to represent zeros, sorry, if I am going to represent ones, can I able to represent zeros? See, if I am going to construct a circuit for ones, can it work for zeros? It won't. If we are going to give this expression, something like this, I have constructed circuit like this, right? This circuit is meant for producing the one for certain kind of inputs, right? If I am going to give other than those inputs, is it going to produce output 0 or not? Yes, that is the meaning, right? So meaning that, which is meant for to define the truth tables, which is the diagram representation of truth tables, where this truth table contains zeros or ones. Those zeros or ones are used to represent these K-maps, right? So for example, this truth table contains this data, right? This diagrammatic representation means it will look like a kind of a square representation. A square representation meaning that it is a collection of cells. It is a collection of cells. So how many cells are there for each and every K-map? That is what my question. See, if I would like to discuss the K-maps, K-maps is another way representation for truth table sum, right? So how we are going to represent the another way? You can able to simply represent in the form of some table format. Those table contains how many cells, right? If I am going to have n variables, how many values I can able to support? 2 power n values I can able to support. Am I right? Right. If I am going to have two Boolean variables, how many minterms you are going to get? 4 minterms. If you are going to have 3 Boolean variables, how many minterms you are going to get? 8 minterms, right? If I am going to have n variable, you are going to get 2 power n minterms, where each and every minterm is going to represent it as one cell. Minterm I am going to represent as one cell, right? If I am going to say that k as 2, I can call it as 2 variable map. If I am going to say that it is a 2 map, I can call it as 2 variable map. 2 variable map means how many cells are there? 2 square cells are there. 2 square cells means it will be like this. Okay. Is there another way are you going to get? So try to observe. If I am going to have the data like this, AB as input, you are going to get XOR gate as output. Assume that this is my logic function. 0 0 as input, 0 1 as input, 1 0 as input, 1 1 as 1 input, right? So 0 1 1, I think 0, right? So in order to represent these two variables A and B, you required 4 minterms. 4 minterms, right? With the help of these 4 cells, can I able to represent or not? Yes, I can able to represent, right? So try to observe. I will write like this. This is A side, this is B side, right? A variables possibilities are what? 0 and 1. B variable possibilities are 0 and 1. 0 and 1, right? Now, what are the combinations we are going to get? One combination is 0 0. Try to observe. 0 0. Another combination is 0 1. Another combination is 1 0. Another combination is 1 1, right? Sir, is this the way only I need to represent? No. You can able to alter its directions also. Sometimes you may get like this, but the way that you are trying to define is important, right? You are trying to read now, this is BA, not AB. Not AB, right? So now this is 0, this is 1, 0 and 1, right? So now what are the values? 0, 0, 0, 1, 1, 0, 1, 1, 1, 1 only, right? So this is the representation for two variable map, right? How this is used for the minimization purpose. Try to observe. So now where the ones are available for me? At 0, 1, right? At 0, 1 I am going to place one min term, that is 1. At 1, 0 I am going to place one min term called 1. I have placed, right? So if I am going to place 1 and 1, is there any problem? Nothing, right? And what about these zeros? Can I place zeros here? If you want, you can place zeros. What does this 1 means? Min term. 1 means min term, 0 means what? Max term, right? Meaning that this table I can represent like this: summation of 1 comma 2, summation of 1 comma 2. Is it okay? Right? Another way is I can represent as product of pi of 0 comma 3, right? The same thing here also, right? Try to observe. How can we represent this particular representation? This is AB, not BA. AB. When you are trying to represent in the AB form, 0, 1 results to 1. What is 0, 1? How to read now? You have to read like this: AB. You have to read from top to left. Okay, na? So you have to, the way that you are trying to declare is important. You have to read from top to right. So when you are trying to read here AB, then only you will get the same meaning, AB, right? AB value is what? AB value is 0, 1 means 1. What is 0, 1 now? See, this is incorrect. You have to do like this. See, don't worry, once you complete the examples you can able to get clear idea, right? So now this is what? 0, 0. This is 0, 1 or 1, 0? 1, 0, not 0, 1, right? This is what I am writing according to this truth table. According to this truth table, this is what? 0, 1. This is what? 1, 1. Right? Now try to write the values. For 0, 1, 1. For 1, 0, 1. For 1, 0, 1, I am going to write the values again. The values again. Both are same. So in this, like, is it a complete cube? There is no problem. Okay. So product of 0, 3. 0, 3. I can write, right? But how these particular maps are used for the simplification? That is our question, right? So here, so the simple logic what you have to follow na, when you are trying to simplify an expression, through K-map method, you have to group, or you have to select a subcube. You have to select a subcube in such a way that that should be in the powers of 2 power m cells. You have to make a subcube that should be in the powers of 2 power m cells, right? So if you are going to make a subcube of 2 power m cells, it means that each and every respect to cell having m adjacent cells. M adjacent cells. I hope you understood. Is it okay? Right? If are unable to like understood, let me try to go with an example, which we'll discuss later part. Don't worry about like what is the exact meaning of this 4 variable map, right? So try to observe. I am going to say that, see, this is also a kind of a K map. How many cells are there here? 16 cells. 16 cells means what is a variable map? This one, 4 variable K map. This is a 4 variable K map. So 4 variable K map means here it is AB, here it is C. See, just for sake of this understanding, I am trying to say. Try to observe. This is 1, 1, 1, 1, right? So you have to make a subcube. So can I call this center as a cube? Yes. So subcube ఎలా ఉండాలంటే, you have to make a subcube that should be in the powers of 2. Is it in the powers of 2? Yes. So it is in the power of 2 square. 2 square. When I say that it is the powers of 2, if I take a cell called this cell, if I take a cell called this red mark cell, that cell is adjacent with how many cells? 2 adjacent cells. Observe, this red mark cell is adjacent with this one and this one. If you take any cell, it is going to have m adjacent cell. That is the meaning of it, right? Fine. So now try to observe. Uh, in this particular example, how can you make this particular subcube? Is there any chance to make a subcube here? What are the possibilities of subcube? It will be 2 power 0, 2 power 1, 2 square, right? Is there any chance to have 2 square subcube? 2 square subcube, it is not possible, because how, when it will be the 2 square subcube possible? When all are ones. When all are ones, I can able to have the maximum cell of 2 square cell. But there is no chance for maximum of 2 square. So is there a chance to have 2 power 1? How? It's not, right? See, these two are not adjacent. These two are not adjacent. So I can have a possibility of 2 power 0. So I can make this as one cell, this as one cell, and I can make this also one cell. This as a one cell, right? So once I make a subcube, then I can able to write the expression for it, right? So try to write. I am trying to do here. AB, here it is 1, here it is 1, this is 0, 1, 0, 1, right? As I made this as a subcube, what is the value of this subcube? So every subcube will act as a one min term. One min term. If I am going to take one as like one as a value, right? Then how many min terms are there? If I am going to have n subcubes, if I am going to have uh, n subcubes are there, how many min terms are there? If I am going to have n subcubes, I am going to have n min terms, right? Observe here, I am going to have 2 subcubes, so I am going to have 2 min terms. What are those min terms? What are this one represents? Try to observe. 0 1 means what, ma? A bar B, right? This 0 1 means what? This is 0, this is 1. 0 means A bar, this 1 means B. One more min term is there. What is that min term? A, B. A, B or B bar? B bar, right? I got the expression again, right? So truth table, so through truth tables also I got, through came up also I got the same result. Is it okay? Okay, fine. Now try to take some examples. I have the variables like AB, my expression is like this, meaning that it contains 1 1 1 1. What is the minimized expression? What is minimized expression? Try to represent in the form of zeros and 1, right? This is 0, this is 1, 0 and 1, 0 and 1, right? What is the minimized expression? Right? So try to form the maximum subcube. So what is the maximum subcube possible here? 2 square. 2 square is there? No. Why? 2 square means what? 4 1 should be there. 4 1s are not there. So what is the next subcube possible? 2 power 1. When it is 2 power 1, is it possible? It is possible, right? When I am saying that it is possible, what you have to think? Is it adjacent to one among other or not, right? So if I take this one, is it adjacent to this one? Yes. If I take this one, is it adjacent to this one? Yes. Yes. So I can say that I can form a cube of size 2 power 1. If I form a cube of size 2 power 1, I formed it. Okay, done. Right? Now, once I form this expression, what is the expression you are going to get now? Right? You have to make the expression for this, right? So what is this value? 1, A, A. And what is this expression value? 0. What is the expression value? 1. So 0 and 1, when you are going to add, it is going to be removed. What is the meaning of this one, ma? This 0 means what? B bar. This 1 means what? B. B bar plus B is what? 1. So finally this expression is yielding to NA, right? If in our terminology, if you would like to say this one, how we are going to write? How we are going to write this one? 1 0. How we are going to write this one? 1 1, right? 1 0 means what? AB bar. 1 1 means what? AB, right? Try to take out the common as A. You are going to get B bar plus B, which is equivalent to again A. So both are same, right? This is the way you are going to solve the expression, right? So try to take out one more expression. Now, right here, how many min terms you got? As there is only one subcube, we got one min term, right? Similarly, try to solve this one. So is there any possible to form a subcube of size 2 square? No. Can I form a subcube of size 2 power 1? Yes. Right? Can I form a subcube of like this? Yes. Right? If I form a subcube of size this, what is the answer for this one? A. Right? A means what? This one. And in other terminology, if I would like to say, when you are trying to combine two cells, if there is any opposite 0 and 1, you can just make simply cancel that. And you can just simply take this one. So 1 means what? A. For this one you got A, right? For this one, is there any 2 power 1 cells? Yes, right? Is there another chance to get 2 power 1 cells? There is a possibility, right? So you may think that it should not happen, but it need to be. This is also one kind of 2 power 1 cell is possible, right? If 2 power 1 cell is possible, what is the answer for this one? B. Yes, right? So this 0 and 1 are going to be removed, so it will be act as a B. So what is the final expression? A plus B is my final expression after simplification of this truth table. So meaning that, so I am going to construct now. Now I hope we got clarity, right? You are going to have input like this: 0 0 0 1 1 0 1 1. What is the output? Output will be 0 0 is 0, 0 1 1, 1 0 is 1, 1 1 is 1. If you are going to solve this expression, you are going to get A plus B. How we got this A plus B? So basic expression is what, ma? A bar B plus AB bar plus AB. You have to solve this expression first. If you are going to solve the expression, again you are going to get only A plus B. That is the advantage of K-maps. K-maps, right? So sometimes you may get certain doubt, like, sir, why can't I add like this? AB, you got the same data only. Sir, why can't I take this as one min term and this as one min term? Right? If I take this as one min term, so you have to choose in such a way that should be maximum subgroup. If it is not happen, what will be happen? This one represents what? 0 and 1. So you are going to get what? A bar B. A bar B. And this term represents what? A. You are going to get again A plus A bar B. Again A plus A bar B means what? A plus A bar into A plus B. A plus B. This is going to be common. Take out. So you are going to get again A plus B. Right? So you have to choose such a way that should be maximum subgroup. Even they are going to be overlapped. They may be overlapped, but it should not be completely overlapped. It should not be completely overlapped, right? So try to take out this example. So I am trying to take maximum extent of example sum, right? So this should be AB, assuming that all ones are there, right? Now what is the maximum subcube is possible? 2 power 2. 2 power 2. If all maximum subcubes are possible, this is 0 1, this is 0 1. What is the result? What is the result? This is maximum subcube. What is the result you are going to get? You are going to get 1, 1, right? Other situation you may think that, sir, can I do like this? It should not happen. If you are going to do, what will happen again? You are going to get one more min term. Already you got one complete min term. That is a part of it. So it should not happen, right? Even if you try to do this one, what will happen? 1 plus A you are going to get. 1 plus A is equal to again 1. So you should not have to do a min term which is a subpart of completely another kind of subcube. Another kind of subcube. Okay, fine. So this should not be correct. Okay, fine guys. If you try to observe this particular thing, I will add one more point. So 1 1 is there, AB is there, 0 1 0 1. As I am trying to do here minimization, I try to combine two cells. If I try to combine two cells, what is the min term we got here? Yeah, right? So when you are going to combine two cells, you got one variable. What is the meaning of son? When you are going to make 2 power m cells as one subcube, as one cube, you are going to get the resultant expression with m minus n literals, with m minus n literals, right? So how many literals are there? How many literals are there here? Two literals. So how many cells you are going to combine? 2 power 1 cells, right? N value is 2. So here n value is 2. Here m value is what? 1. So final how many are you going to get? N minus m, that is 2 minus 1, which is 1. 1 literal. Is it 1 literal or not? That is the thing you have to understand, right? So number of min terms you are going to get in the expression is equivalent to number of subcubes, right? And each and every min term length, each and every min term length or each and every min term size is depend on what? Size of subcube. You have to understand this point also. Each and every subcube size is depend upon, each and every size of min term is depend on size of subcube amount. Am I right or not? If it is a maximum subcube, I am going to get very less, very less. That is what the meaning. Okay, fine. This is one way. So meaning that if you are going to have some of the products expression, you are going to get something like xy plus x bar dot y bar. You got an expression, right? So if you got this expression, if somebody asks you to try to solve this expression, can you able to solve it? It is already in solving only, but you don't know. Assume that. So can you able to solve it? Yes, we can able to solve it with the help of K map. How many variables are there? Two variables. F of x comma y equal to two variables are there. That should be x y. This is 0. This is 0 1. Right? What is this value? 1 1. What is this value? 0 0. Right? In those places you have to place 1 1. Right? So meaning that if it is in sum of the product expression, okay. But sometimes you may observe x plus yz. Can you able to directly write? Okay, so this is again a third variable terminology, so that will come across next point. So can you try to express this one? So you are going to get this as what? 1 1. In 1 1 place you are going to place 1. In 0 0 place you are going to place 1. And how we are going to minimize it? This will be the single one, this will be the single one. You are going to get the same expression, right? Okay, fine. Now for example, there is an expression called f of x comma y equal to x plus y into x bar plus y bar. So what is this expression? Product of sums, right? If it is product of sums, how we are going to write in the form of K map? There should be xy, right? If it is product of sums, you have to take out zeros. You have to take out the zeros, right? So what is the value of this one? Right, this is 1 1, right? Sorry, 0 0. So in product of sums, it is x as 0, x bar as 1, right? 0 0 means what? 0 1 0 1. 0 0 means what? I have to place what? 0. It is I am trying to think about product of sums. What about this one? 1 1. Again 1 1. Here I need to place 0 0. Place 0 0, right? Now this is a min term. This min term how we are going to write? It should be in the form of product of terms. Product of terms, right? As I am trying to write in the product of sums, it should be x plus y only. Why x plus y? X is 0, y is 0. as I'm trying to write it in the product of sums, I have to write like this. This should be x bar plus y bar, right? So if you'd like to minimize it like subcube, you have to do like this. Okay, fine. So this is what you can able to do with help of two variable k map. Similarly, if I'm trying to say that it is a kind of three variable map, three variable map, three variable map, what are the possible values you are going to get? A, B, C as inputs, right? If A, B, C as input, how many cells you are going to get? Two cube cells you are going to get. If it is two cube cells, how can you represent? Can I do like this? Can I do like this? How many cells you got? 8 cells, right? So now these are values what 0 and 1. So 0 and 1 values I am going to get with only single variable j, right? 0, 0, 0, 1. So if you would like to have 4 possible values, you have to have two variables. Two variables, and you have to make sure one point here. This should be 1, 1. This should be 1, 0. Right? So in gray code is meant for what? Mirror representation, right? As I'm saying that it is a cube will look like a kind of cyclic code, right? If you would like to get a cyclic code, what I said, each and every min term should have to differentiate with only one bit, right? If you try to observe here, from 0, 0 to 0, 1, how many bits are changing? Only one bit. 0, 1 to 1, 1, one bit. 1, 1 to 1, 0, 1, 1. One bit only. If you try to take out 1, 0 to 0, 0 also, you are going to change only one bit. This is what. So that's a, as I am trying to represent the form of a cube, that you have to represent the form of like this only. Okay, fine. Now I am going to have values. I am going to have values like this. Values like this. What is the meaning of this one? So can I write what is the positive values this one here? 1, 0, 0. 1, 0, 0 is one possible value. 1, 0, 1 is one possible value. And this is what? 1, 1, 1 is one possible value, right? I can directly write as f of 1, 0, 0 or f of 1, 0, 1 or f of triple 1, right? Meaning that if I are going to have expression with A, B, C as inputs, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, triple 1. What is the outputs, ma? Resulting function is what? For 1, 0, 0, 1 is output. For 1, 0, 1 is 1 is output. For triple 1 is output. For all the cases, output is 0. Right? This is expression is what? Sum of the products expression. Right? If it is saying that it should be product of the expressions, you have to take out the zeros. Right? And all places you have to make zeros. Right? And if you would like to simplify the expression, how we are going to simplify? You have to take out the maximum powers of the subcube. Is it 8 subcube is possible? No. Is it 4 subcube possible? No. Is it 2 subcube is possible? Yes. I can make this subcube. Okay. If I make this subcube, what is the value? You are going to take out these two values, right? In these, what are the values are changing? 0 and C value is changing. So you have to eliminate C. What is the value is not changing? B. B means what? 0. 0 means what? B bar. What is the value is not changing here? AB bar. So with this expression, with this combination of 2, I got AB bar. So that is the meaning of it, right? If I am going to combine 2 power 1 cells, how many literals you are going to get? M minus n literals. N variables. How many n variables are there here? 3 variables. How you combine? 2 power 1 cells are combined. 3 minus 1 is 2. So you got this. Right? Similarly, I can able to combine like this. What is the data you are going to get here? A plus, sorry, A C. AC, right? So AB bar plus AC is the minimized sum of the products expression, right? So try to take out one more equation. 0, 1 ABC Guys, try to observe now. How we are going to combine? How we are going to combine? So it is not possible to combine with 8, not possible to combine with 4. Is it possible to combine with the 2? Yes. Guys, can I combine which 2? Adjacent, okay. Right, you have to select that, right? 0, 0, 0, 1, it should be 1, 1, then it is 1, 0, right? So the reason why I have mentioned this also because of adjacent only, right? Now which 2 I can combine? Can I combine top 2? There is no problem, right? If I combine top 2, what is the value you are going to get? You are going to get A as it is. So A means what? A bar. What about the above level which are changing? C is not changing. So you can take directly A bars. A bars, right? Now, don't worry about that expression. So consider only this. Now what is the value? How can you combine? Is there any chance to combine? No. Assume that it should be a cube. If it is cube, is these two are adjacent or not? If you observe, it is a cube, right? Or else you can understood 0, 0 and 1, 0 are adjacent or not, because one bit is changing. So I can combine like this, right? So this cube is going to produce what is the value? A, and what is not changing? B bar. So the result is A bar C plus A bar A B bar. Is it okay? C number? Okay. It should be C only. It should be C bar. A bar C plus A C bar. Okay, try to think this one. Can you do now this representation? How many cells are there here also? 8 cells. I can also represent like this, right? So I can say that this is AB. I can say that this is C. Right? So anyway you can represent, the way you are going to represent. This is 0, 1, 0, 0, 0, 1, 1, 1 and 1, 0. Right? Or else you can take out this as BC, and this can be A. Or sometimes they may give as AC followed by B. ఎలా అని ఇవ్వచ్చమ్మ, that depends upon their requirement. AC అని ఇవ్వచ్చు, then B అని ఇవ్వచ్చు. That depends, right? So you can able to represent either in any of the form. So in two variable map you didn't get any difference because of it is completely a square, right? So now if they have given the values like this, what is the value? How you are going to group? Can I group these 4? Yes or no? If I group these 4, what is the value of this one? Is there any C value? No, because it is already altered. 0 and 1 are combined. What is about this one? You are going to get B because A is changing. A is changing. Okay, fine. So for this cell you got B, right? This is the meaning, right? If I am going to have 3 variables, I am going to combine 2 square cells, meaning that n value is 2, right? 3 variables ఉన్నాయి, 2 variables తో combine చేస్తున్నామంటే resultant variable contains n minus m literals. So that's what meaning. So one literal is there. Now how can I combine this one? These two I can combine. Can I combine with 1? I can do with combine 1 also, but the problem is you are going to get more number of literals. So you have to make a subcube in such a way that should be maximum. Okay, fine. So it should be, what is the value of this one? This should be A C bar. So this is the final expression. What is the value? What is the value after solving the expression? How we are going to combine? Can I combine with 4 cells? Yes. So can I combine these 4? Can I combine these 4? Yes, I can combine, because if I are going to take one cell, that cell is adjacent with 2 cells or not? Yes, this cell is adjacent and as well as this cell is adjacent. So I can combine these two, these 4. If I combine these 4, what is the value? A. Because these are all altering, so I can take only this one. Now, what is another one? Can I take 2 or 4? 4. I can take 4 because I need to maximum sum these 4. If I group these 4, A value won't get, and you are going to get C. So the final expression for this one is A plus C. Okay. Now try to combine. Now, how many cells are you going to combine? Can I combine with 2 cells? Yes. If I combine with 2 cells, can I get this data? Yes. What is the value? A bar, B bar, right? Similarly, can I combine these two? Yes or no? If I combine these two, what is the value you are going to get? A, C. A, C. Is there another combination are you going to get? Yes. You are going to get another combination as like this. What is this combination yielding to? B bar C. B bar C. So just think that now is the expression is finally minimized expression? No, it is not finally minimized expression, right? So because you have considered here this black color circle also, right? This black color circle is already covering the remaining 2 minterms. Am I right or not? Right? So that's the reason this is a kind of redundant. This is a kind of redundant, right? So this will look into later part. Later part means after 10 to 15 minutes we can come across again the same concept. How we are going to find out this kind of thing, right? So for the time being, A bar B bar plus AC plus B bar C also correct. But the thing is, the B bar C is a redundant expression here. Now, try to take about the 4 variable map. So if I am saying that 4 variable map, 4 variable map, A B C D, here only one kind of representation is possible, right? Because it's completely a square. Right? What are the values? 0 0 0 1 1 0 1 1 0 0 0 1 1 1 1 0. Okay, fine. Now, if I am going to have an expression like this, 1 1 1 1, like this, how can we combine? Can I combine first all the 4 in which are in single column? Yes. If I combine all the 4 in a single column, what you can do? What is the value? You are going to get CD. You are going to get CD, right? Similarly, what are the other combinations? Can I combine these two? Yes or no? I can combine these two. What is the value you are going to get? You are going to get A bar B, and these two which are changing. D is changing, so you have to eliminate. So you will get C. A bar B C, right? Is there another combination? Is there? Another combination is there. These two also possible, right? So if I take these two, what you are going to get? Again A bar B. What is the value? A bar BD. Here you have to think like it should be C bar. It should be C bar. A bar B, C bar. This is possible, right? So what is the meaning of this one? So I have to eradicate this also. I have to remove this red color also. Here I have to remove this black color also, right? For that we will come across that later part. Okay. So try to check here. What is the meaning of this expression? A B C D 0001 1011 0001 1110. So this should be 11. This should be 10. Okay, fine. Try to like I am trying to represent the values like this. Right? What is the expression value? First, you are going to combine these four. What is the value you are going to get? AB. Then you are going to combine. Can I combine these four? Yes or no? What is the value you are going to get? I think A is not changing. Here D is changing. So AD, and can I combine these four? Yes. What is non-changing? A is not changing. C is not changing. So if you observe, what is this expression? AD plus AC plus AB, AB, right? Which is equivalent to the starting of the expression, right? If you are able to observe, this is the expression we got. This expression we got. What is the outcome we got? AB plus AC plus BD. AB plus AC plus BD, right? So if you open your notes and try to write down these values for the expression, right? So what is the value of this one? This particular value is 1100. This particular value is 1101, and next value is 1111. Next value is 1100. Next last line value is 1001, 1011, 1010. Meaning that this should be like 12, 11, or 13. 13, 15, 14, 9, 11, and 10. Right? If you look into this first example, if you are going to write those values in the decimal value, you are going to get those values only, right? See, observe now, as I am going to have a large expression, trying to solve it in the form of Boolean theorem is a difficult thing, right? You face a lot of hurdles here in order to get this expression. Am I right? The same thing you got in a simple way. In a simple way, that is the advantage of K-maps. Okay, so how can you write the same expression? Sum of sum of 9, 10, 11, 12, 13, 14, 15. 13, 14, 15, right? Now, if I would like to write its opposite side, right? It should be in the form of product of the sums. What is the value you have to write? You have to write compulsory 0, 1, 2, 3, 4, 5, 6, 7, 8. This is not complement. This is not complement. This is in the form of product of the sums. The result is in sum of the products. If you would like to come up across the product of sums, you have to make like this, right? So that also, this should be in standard sum of the products. This also should be in the form of standard product of the sums. That is what, right? See, if you are going to have an expression like this, x plus yz, how can we represent in the form of k map? What is the variable? How much variable k map you require? 3 variable k map is required. Is it okay? 3 variable k map is required. That is x, y, z 0001111001. What is this value? Triple zero. Triple zero, right? Meaning that this expression you cannot able to directly represent. So what you have to do? you have to first convert it into standard sum of the products, then you have to make it representation. So that is the advantage of canonical forms, right? So canonical forms are used for to represent your data in K-maps, right? So how can we convert this into standard sum of the products? X into y plus y bar, z plus z bar, plus x plus x bar, yz. Try to solve this one. You are going to get, I think, xyz, xyz bar, xy bar z, xy bar z bar is all done. 4 expressions, 4 combinations you are going to get. Then you are going to get xyz, x bar, yz. Right? Now through this expression you can represent. That's it. Right? So if you would like to represent anything in the form of K-maps, compulsory those should be in the form of standard sum of the products or standard product sums. That you have to remember, right? Now what is the value of this one? This value is 1. This value is 1, right? So you can able to remove the redundance. XYZ is redundant, XYZ is redundant. I can able to take out 1. Because A plus A is way. Is there any redundancy are there? No. What is the value of this one? 110 is 6. This is 101 is 5. 100 4. 011 3. Right? So in place of 1, so how can you remember this one? This is 0 1 2 3 4 5 6 7. Here also you can do simply 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 and 15. So by just making a practice you can able to write. Okay, fine. Now how can you represent? In place of this one I am going to represent like this one. In place of 6 also 1. In place of 5 one more 1. 4 one more 1. And 3 you are going to place one more 1. How can we combine this one now? I can make combine of these two. 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 Am I right or not? Because those are some of the possible subgroups. Okay, fine. So now try to check. Now try to check. If I am going to write this, if I am going to write this in the form of pi of 9 comma 10 comma 11 comma 12 13 14 15. What is the meaning of this one? In place of all ones, what you have to place? You have to place zeros. When you place zeros, how you are going to write this one? 1 will be represented as normal A bar, 0 will be represented as A. So meaning that when you are going to write like this, now it is the complement. It is the complement, right? If you want, you can just write that. So if you take the first one, here you are going to get A, B, C bar, D bar, right? I think you got A, B, C bar, D bar. A, B, C bar, D bar means what? Double 1, double 0. Double 1, double 0 is 12. 12, right? So for this, if I place 0 in place of 12, if I place 0, how we are going to write this one? You are going to write as A bar plus B bar plus C plus D. Is it a complement or not? A complement is what? Every letter you have to change it to complement. Every dot you have to change it to plus, plus change it to dot, zeros place to 1, 1 place to zeros, right? So meaning that if you write like these two are nulls, these two are complement each other. Summation of all numbers, the same numbers having projection, you are going to get complement. If you are going to get, if you want to get sum of the product of the sums, then you have to take out all the remaining zeros. Remaining zeros. Okay, fine. Try to take out this one. I would like to take ABCD. What is the value of this one? What is the value? How many minterms you are going to get? 4. Is it 4 minterms? Only one minterm. Because it's a cube, right? When you make cube, all corners equivalent to one adjacent, right? Right? If you want, you can able to just understood. So what is this value? This value is 4 zeros. This value is what, ma? 0 0 1 0. 4 zeros, 0 0 1 0. How many bits are changing? One bit is changing, so they are adjacent. If you take this also, 4 zeros and I think 0 1 0 0. How many bits are changing? One bit is changing, so they are adjacent. If you take this also, 1 0 1 0 1 0 1 0 and take out the another number, these two, 1 0 1 0 double 1 1. So these two, is these two, how many bits are changing? One bit are changing, so they are adjacent. So finally, what is the value of this expression? How many are changing? This 0 0. So this 0 is not changing, right? So this 0 is not changing, so this is b bar, and this 0 is changing, and this will, so this should be like b bar b bar. So like this also you can able to come. Am I right? Okay, fine. So for like as I have taken earlier, I am going to take one more possibility. Right? For example, all ones, 1 1 1 1. How many minterms you are going to get here? How many minterms you are going to get? Can I combine these four? Yes or no? Can I combine these two? 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 You are going to get 5 minterms. You are going to get 5 minterms, right? But thing is, out of these 5 minterms, there is a one minterm which is again duplicate. What is that? The middle bigger one. Why it is duplicate? Because if you are going to take this one, it is covered by this expression. If you are going to take this one, it is going to be covered by this one. If you are going to take this one, it is going to be covered by this one. If you are going to take this one, it is going to be covered by this one. So the middle one is a kind of irredundant expression, right? So that reason, what we can do now, we can able to find out, which are important, meaning that which are primarily important, important. Those are I can call it as primary implicants. Those are I can call it as primary implicants. So what is the meaning of first implicant? Implicant means whatever the term that you are going to get as a one implicant, right? Here, how many implicants you got? 5 implicants you got. 5 implicants you got. Out of those 5 implicants, what are primary implicants? That is my question, right? So simple thing is, try to observe. If I am going to say that A is one function, A is one function, FA is one function. So 00001, assume that. FB is one function. It is having the data like 0 1 0 1. Guys, now try to think, is FB is able to solve the problem of FA or not? Meaning that whatever the terms that are available for FA function, is it a part of FB or not? Is a part of FB or not? Yes. So I can say that FB is covering FA, meaning that there is no need of FA where FB itself is going to solve the task. Am I right or not? Meaning that FA is an implicant of FB. Or I can say that FA is a subpart of or subset of FB. Right? Meaning that if I am going to draw an expression for FA, what will happen? The expression is again a part of FB. Am I right or not? See, if I'm going to have the values like x and y, x and y, what is this value? Xy. What is this value? I think 0 1, right? 0 1 means x bar y. This is what? Xy. Xy is an expression is subpart of x bar y plus xy. That is the meaning of this one, right? Meaning that FB itself is going to cover FA. Am I right? So here, if you are able to observe, here if you are able to observe, the expression, the expression, this expression is going to cover this one, right? Then why we need to include this one? That's the question. So, so everything we can call it as an implicant. So if somebody asks you to find out how many implicants are there, how many possibilities you are going to get, all those possibilities you have to write, right? So here, if you would like to reduce the redundance, you have to identify prime implicants. Prime implicants means which should not be subpart of other implicant. This should not be subpart of other implicant, right? If you are going to take an implicant that should not be subpart of other implicant, I can call it as primary implicant. Primary. Is there any like non-primary implicants? What is the meaning of primary implicant? So if you are going to take one implicant, that should not be part of other implicant, right? So try to take out this expression. Try to take out this expression. Is this subpart is a complete subpart of other? No. So A is not complete subpart. Observe, I am trying to give the name C, D, E, sorry D, and middle is E. Middle means what? All four. Try to observe. Is A is subpart of E? No, it's not subpart. It's a just a part. B is subpart of E? No. D is subpart of E? No. C is subpart of E? No. Am I right? So then I can consider it as 5 prime implicants are existing. 5 prime implicants. I can say that every prime implicant I can call it as an implicant, right? 5 implicants are existing. Implicants are existing. Okay, fine. So now here, how can we? So I hope you understood that this is a redundant term. So how can you remove this redundant term? So for that, you have to understand one more terminology, that is essential prime implicant. Essential prime implicant. What is the meaning of essential? That is compulsory. That is compulsory, right? So if I am trying to say, if I am trying to say a prime implicant as essential prime implicant, so if I am trying to take one prime implicant, that should have to cover, that should have to cover at least one cell, at least one cell which is not covered by any other prime implicant. If I am trying to say that as a essential prime implicant, essential prime implicant, the prime implicant should have to cover at least one prime, at least one cell which is not covered by any other prime implicant, right? Here what are the prime implicants? A, B, C, D, E are the prime implicants. Okay, fine. Among those, what are essential? See, if I include D as essential prime implicant, D as essential prime implicant, what about A, B, C, and D? Those are also essential. Why? Those expressions also need to be evaluated, right? So if you want to evaluate those, I have to cover those also by using again subq, again subq. Other way, so but if you think about other way, if I am going to take A is one essential prime implicant, B is one essential prime implicant, C is one essential prime implicant, D is one essential prime implicant. Okay, why I am saying that essential prime implicants? Because without involving these four, you cannot able to cover this one or this one or this one or this one or this one. But can I say now E is essential prime implicant? No. If you would like to say E as essential prime implicant, that has to cover at least one extra cell which is not covered by any other prime implicant. Is there any extra cell that is covered by this essential prime implicant? No. right? This one is covered by A, this one is covered by B, it is covered by D, it is covered by C. So E won't comes under essential prime implicant. I hope you understood the terminology, right? So try to think one more example. One 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 one, right? A B C A B C. If you take 0 0 0 1 1 1 1 0 0 1 0 1, how we are going to combine now? First, try to identify all the essential prime implicants, right? Or else directly find out all the prime implicants first, right? So this is a one prime implicant, this is a one prime implicant, this is one prime implicant, and this is also one prime implicant, right? Why I am saying that middle one is prime implicant? Because it is not part of any other prime implicant, right? So I got A, B, C are the prime implicants, right? So how many prime implicants are there here? 3 prime implicants. What are the essential prime implicants? Essential prime implicants are only A, comma C. Why? AC is going to cover 000 001. C is going to cover 101 111. But if I take B, B is going to cover what? 001 and 101, which is already covered by other prime implicants. Already covered by, so B is not an essential prime implicant, right? If I am saying that it should be essential, that has to be unique, that has to identify at least one extra cell which should be covered by, which should not be covered by any other prime implicant. So that is the meaning of this one. So how many essential prime implicants are there here? 2 essential prime implicants are there, right? So in simple words, to avoid the confusion for you, I have a simple procedure. Like for example, try to take the same thing. ABC 0001 11 10 01. So I think this one, right? So basically, you are going to have these two are combining, and these two are combining, right? But you can able to identify essential prime implicants are two according to your basic some kind of common sense with knowledge, right? Okay, but there are certain kind of problems where they are very huge. At that situation, this solution is helpful for you, right? How can you do means, so try to identify all the prime implicants. What are the prime implicants? Can you able to identify? They should not be part of other, right? So what are the prime implicants? A bar, B bar, C bar. A bar, B bar, C bar. You have to take the total term. So what is the total term you are going to get for this expression? What is the total implicant, prime implicant? A bar and B bar. For this, what is the, is it a prime implicant or not? What is the expression? You are going to get B bar C. Very good. What is the implicant? You are going to get A C. Very good. A C. Right? Try to write at one side. At one side, right? And wherever the ones are there, try to write out all those in the top side. What is this one reference? 0. What is this one reference? 1. What is this one reference? 101. 5. What is this one reference? 111. 7. 7. Right? So now, once you are written like that, what you can do now? Try to represent for what reason you got A bar B bar. For what reason you got A bar B bar? Because of the combining of 0 and 1. Because of the combining of 0 and 1, you got A bar B bar. What is the reason for combining? What is the reason for getting B bar and C? Because of the combining 1 and 5. 1 and 5. What is the reason for getting AC? What is the reason for getting AC? You are getting because of 5 and 7. Because of 5 and 7. Then 5 and 7, right? Once you mention like that, the simple thing is, you have to identify a column where the column having only exact one number, right? What are the columns having exact one number? This is the column or this is the column. You can able to start with anyone. If I am going to include this as my expression, this as my expression, it has to complete this one, right? So this one also be included. If I am going to consider this as one expression, I have to consider this entire thing. So this will be as one expression, a bar b bar, right? Now try to find out. Now try to find out one more expression where which is going to cover the remaining things, right? So what you have to do now? You have to remove this complete expression, and you have to remove this also, and you have to remove this also. Why I have removed this and these two? Because they already covered by this a bar b bar, right? Now from the remaining, try to find out the column which is having a single number. So I have got 7. I got 7. So if I include 7, I have to compulsory include its corresponding one. Its corresponding one. Its corresponding one is also 5. So 5 7. So next term is AC. AC. If I include this, I have to remove this column. I have to remove this column. If I remove this column, is there any terms need to cover? 0 1 already covered. 5 7 already covered. So there is no other requirement to cover. Requirement to cover. So these are the essential prime implicants that we need to find out. Right? If they are asking prime implicants, what you can do? You can simply find out they are subpart or not. You can able to do, right? So try to take out one more. So the same example, A B C D, A B C D, right? I think what you have discussed, right? All 4 ones. I think this one, this one, this one, and this one, right? Basically, how many prime implicants are there? 5 prime implicants are there, right? All those five implicants are you can write, right? So what are those five prime implicants? I think this is 0 0 0 1 1 1 1 0 0 0 0 1 1 1 1 0. What is this one reference? 0 1 double 0. 0 1 double 0 means A bar B C bar D bar is the way I have to write. You have to combine, right? You have to combine, right? If you are going to combine, I am going to get with these 4, these two, and these two, and these two, right? Now try to write the expression for this one. This A B C D and E. For A, what is the value? A bar B, A bar B, C bar for A. What about for B? A, A, C bar, D. For C, A, B, A, B, C. For D, A bar, C, A bar, C and D. For E, AB. AB or AC? Sorry. For C, it should be like B and it should be like D. B, right? You have to write this is the procedure. Right? This is for only exam point of view, for competitive exam point of view, right? And what about the top level? All the terms which are represented for the digits 1, right? What are the values? I think this is 0 1 2 3 4 5 6 7 8 sorry 8 9 10 11 12 13 14 and 15, right? Try to write down those values. Third one, third is possible, 4 is possible, 5 possible, 7 possible, then 9 possible, right? 9 possible, 13, 14 and 15. What is the reason for getting A bar B C bar? What is the reason for getting A bar B C bar? What ma? Uh, so you are getting, it is because of 4 and 5, right? So 4 and 5 you have to place ones. What is the reason for getting A C bar D bar A C bar D? Because of 9 and 13. Because of 9 and 13. What is the reason for getting A B C? Because of 14 and 15. Because of 14 and 15. What is the reason for getting A bar C D? Because of 3 and 7. Because of 3 and 7. Right? If you want, you can able to just make some note. Okay. What is the reason for getting BD? 5, 7, 13 and 15. 5, 7, 13 and 15. Right? Once you mention like this, what is the simple solution? You have to identify a column where it has to have only one, right? So I think you can take either 3 or 4. Either 3 or 4. If I take this 3, I have to tick this one, right? As I am including this one, I have to include 1 also. I have to include this respect to A bar C D bar, A bar C D, right? So if you want to get this one, I have to include this also. If I include this, 7 also be considered. So at my final point, I have to have A bar C D is one thing. So you can able to just simply remove this one. Remove this one, right? And you have to remove this also, ma. Tick mark, you have to remove this tick mark also, right? Next, you can take out the 1. Either 4 or 9 you can take. There is no problem. I am trying to take this 4. If I try to take this 4, I am getting the expression A bar B C bar, and I am going to get this 5 also. If I get this 5, I have to get all these read and all these also, right? Next, from these remaining, you have to find out the ones. What are the remaining ones? Either 9 or 14, single ones, right? I can take out the 9. If I take the 9, I need to take 13 also. So 13 will be ticked, right? Then I am going to get A, C bar, D. So I am going to remove this as well as this, right? Next, what is the remaining? Single one, right? This one, 14. I need to tick this one. So 14, 15, if I am going to include, I am going to get A, B, C. I need to remove this as well as these columns, right? Is there any remaining ones are available for me? No. So these are the 4 essential prime implicants, not the prime implicants, right? Those are the 4 essential prime implicants as well as prime implicants, right? How many prime implicants are there here? 5. How many essential prime implicants are there? 4. That you have to remember. How many implicants are there? Again, 5 only, right? Right. So for example, try to write a question. Which of the following which of the following are prime implicants are which of the following prime implicants are essential? Which of the following prime implicants are essential? They have given the K map. So try to solve A B C 0 0 0 1 1 1 1 0 0 1. There should be like 1 1 1 and 1 1. Options are B bar C, A bar B, A bar C, A bar B, A bar B, AB bar, A bar B, AB bar, B bar C. Can you try to find out this one? Option? Right? So basically we can think of this one. So prime implicants first. This is a prime implicant, and this is a prime implicant. This is a prime implicant, and this is also a prime implicant. How many prime implicants are there? So I think this is one, A, B, C, D. So total 4 prime implicants are there. Now among these 4, which are essential prime implicants? Can you able to define directly? Yes sir. How? Any one of the 4? What you have to do? You have to simply follow the same procedure, right? So you have to do, right? So what are the values you are going to get? You are going to get the values as one is A bar B, another one is AB bar, A bar C, another one is BC, another one is BC. And what are the values which are available in one location? 1, 2, 3, 4, and 5. Right? If you observe here, this is 1, this is I think 2, uh, this is like 4. Is it 5? Yes, 5 and 6. Is it 6? Right? Yes, it is 6. So if you are going to take it as a 6, is it correct now? Why 3 I have included? 1, 2, 4, 5, 6. 1, 2, 4, 5, 6. Right? Now try to do this. Where are the ones? So how we got A bar B? Vertical A. Because of this reason. Because of vertical A. Vertical A means what? 1 and 5. 1 and 5. How we got A B bar? Because of this D. 2 and 6. How we got A bar C? Because of this. Because of 4 and 6. How you got BC? Because of this, right? Uh, because of 4 and 5. Because of 4 and 5, you got as B. No, 4 and 5 you have to. Why you got A bar B? A bar B you got because of 1 and 5, right? 4 and 5 you haven't included. So for 4 and for A bar B, what is the result? For A bar B, 1 and 5 is correct, right? What is this one? BC, is it correct? 4C, 4, 5. For 4, 5, what you are going to get? C, okay. A bar C. A bar C is 4, 5. What is 4, 6? What is 4, 6? C is compulsory. C is compulsory. And A changing, right? B bar, right? So B bar C. So B bar C is the correct. Right? This is the one. So from this one, what you have to do? You have to take out the common one, single numbers, right? So try to take out A bar B. If I include A bar B, I have to take out 5 also, right? So you can be able to remove simply these and this, right? A bar B should be in the answer. In the answer, right? If I remove these two, what is another one? I have to include AB bar. As AB bar is including, I have to remove 6 as well as 2. 6 as well as 2, right? A bar B and AB bar, right? Now, now 2 are remaining. Now 2 are remaining. Is these two are essential? Is these two are essential? Try to think. Can I take B bar C as essential, or can I take A bar C as essential? Which one is essential? You can't take anything, right? You can take either one, right? So either one you can take. So your final expression will be A bar B plus A bar B, A B bar, A bar C, or A bar B, A bar B, A B bar, or B bar C. So your essential prime implicants are compulsory, these two, these two, and these two are not compulsory again. Anyone they can able to include. Anyone can. So your answer will be option C. So this is somewhat tricky question actually. That's why I discussed here. Okay, na? Is it clear for everyone up to now? Okay. So, so basically, whatever the circuits that you are going to get, whatever the circuits that you are going to get, so those circuits are basically complete functions. Those circuits are basically complete functions. What is the meaning of complete function? If I am going to give certain inputs as A and B, it is going to produce the exact function value of its output, right? If I am going to say that 0 and 0, its output is 0. If I am going to produce like 0 and 1, its output is 1. If I am going to produce like 1 0, input is 1 0, its output is 1. If I am going to say that its inputs are 1, its output is 1. Meaning that for each and every input, I am going to have certainly one output. That kind of function I am going to call it as complete functions, right? Certain times there are certain kind of functions are there, those are incomplete functions. Those are incomplete functions, right? For complete functions, what are the terms are available here? What are the terms are available? All ones can be included as a complete function, right? One is A bar B, another one is AB bar, another one is AB. This is a kind of a complete function. If I am saying that it's an incomplete function, if I am saying that it's an incomplete function, there should be certain output which you cannot able to define. For example, I am trying to function called fk function 0, 1, pi, and I am saying that this is 1. What is the meaning of this one? In this function, there are certain terms, which I didn't define. There are certain terms, which I didn't define. Those terms I can call it as don't care terms. Don't care terms. You should not care about all those things, right? Meaning that this may ranging from, these may vary from two values. What are those values? At certain times it may act as 0, at certain times it may act as 1. This is what don't care terminology. Don't care means they may act as 0 or they may act as 1. Okay, fine. For example, if I am going to have this meaning, how many functions are possible? One is 0, 1. 0, 1 is one function possible. What is another function? So fk1 is one function. Fk2, what is another function is possible? 0, 1, 1. This is the functionality possible. That is the meaning of don't care. For example, I am trying to define some of the terms of 0, 1, 2, 3, 9 plus you have to consider don't cares 8, 10, 11, 13. Can you able to simplify the expression? right? Try to observe, right? If you take any k map, how we are going to represent, right? So I think I can take some terminology like ABCD. This is 00011110, 00011110. What are the values of this 01239? I think 0, 1, 2, I think 3. What is 9? 1001 is 9. Am I right? 1001 is 9. What about don't cares? You should not care about them, right? So wherever they are saying the don't cares, you have to mark them, right? What is 8? I am going to mark them as don't care, X, cross mark. 10, I think 8, 9, 10, 11, 11 and 12, 13. 12, 13. Now what is the resultant expression you are going to get? You have to consider what are the possible functionalities. In place of this don't care, you may get zeros or you may get 1, right? So now in order to get your expression is very minute simplified expression, these don't cares can you consider or can you may not consider. If you consider, what will happen? If you are going to consider, in place of this cross mark, I am going to consider it as 1, meaning that don't cares I may consider as 0 or 1. If I consider 0 or 1, what I can do, I can combine this as 1 or not. Yes. So I got a maximum of 8 terms. I got a maximum of 8 terms. If I am going to combine maximum of 8 terms, what is the output you are going to get? B bar. B bar. That is the advantage. Guys, can we combine these two now? Can we combine these two? If I combine these two, you are going to get extra term. Why you need to consider? Because it is all, this one is already covered. So you should not consider, right? So that is why you are going to work. Okay. So this don't get terminology you are going to get more understandable when you go with the examples. Okay, fine. There is one more point is there, that is variable entrant map. Variable entrant map, which is an alternative for K map. Where in this variable entrant map, you can able to fit more than n variables. You can able to fit more than n variables, right? For example, if you are trying to take this one, how many variables you can able to fit? Two variables. One is a and another one is b. Can I able to fit one more variable? Basically, it is not possible. But if you go with the procedure of variable entrant map, it is possible. How means? Try to understood. I am going to have three variables a, b, and c. What are the values? 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, double 0, 1, 0, 1, 1, 1, 0, triple 1, right? Now I am going to have a function called f1. This function I am trying to write the values like 0, 1, 0, 0, 0, 1, 1, 0. Right? Assuming that one more function f2, one more function f3. If I am trying to say that f2 0, 1, 0, 1, 0, 1, 0, 1. Assume that f3 as 0, 1, double 1, 0, 1, 1, 0. Guys, just I made some kind of assumption here. F1 you got, F1 function is defining these values, F2 function is defining these values, F3 function is defining these values, right? Now, how can we represent these three variables in a two variable map? That is what my question, right? Try to observe. If I take AB as inputs, can I mention F1? Can I mention F1 in terms of C? Try to observe. In terms of C, can I mention? Try to observe. If I am, what are the possible values for AB? 0, 0, 0, 1, 1, 0, 1, 1. 1 1. If I am going to have the 0 0 as input, 0 0 as input, what is the output? 0 1. Is 0 1 is equal to C value or not? Whatever the input that is given by C, that is getting the same output for F1. Now can I write here C? Yes or no? Yes. Similarly, if you are going to observe 0 1 as input, 0 1 as input, you are going to get 0 as output. Meaning that irrespective of the input C, when you are going to get the input 0 1, you are going to get the output 0. So then what I can write here? 0. 0. Right? Similarly, if you observe here, when you are going to give the inputs as 1 0, whatever the input that you are going to give as C, that is going to produce as output. That is going to produce output. So can I write like C here? Yes. Similarly, when you are going to give the inputs as 1 and 1, what is the output? 1 0. What is this 1 0? C complement. So C complement. Now can you draw the expression for this? A B 0 1 0 1. What is 0 0? C 0 1 0. What is 1 0? C. What is 1 1? C 1. So this is what I can call it as a variable entrant map. Meaning that with the help of two variable map also I can able to represent three variable map. Three variable map. For example, try to solve for F2. For F2, what you can do? If I try to take for F2, here only I will write. If I am going to have the input like 0 0, what is the output? 0 1, which is same as like C. So can I write like C here? If I am going to have the input like 0 1, what is the output you are going to get? Same as C. If I am going to give the input like 1 0, what is the output you are going to get? Same as C. If I am going to give the input like 1 1, what is the output you are going to get? 0 1, which is same as like C only. So this one C. So for this one, if you write a two variable K map, you are going to get all C's. Similarly, if you take out for F3, F3, what is the values possible, ma? If you are going to give the 0 0 as input, you are going to get C. If you are going to give 0 1 as input, 1 1 as output, irrespective of C. So you can write here as 1. If you are going to give 1 0 as input, irrespective of C, you are going to get the C only, right? Meaning that the same C input you are going to get as output. So you can write here as C. What about this one? C. So for this one, variable entrant map is AB 0 1 0 1, right? For 0 0 it is C. For 0 1 it is 1. For 1 0 it is C. For 1 1 it is C. Like this you can able to do, right? But if they have given something like this, if they have given something expression like this, ABC, right? Here 0 1 0 0 0 1 1 1 1 0 1 1 1 0, right? So I am saying that this is a don't care. I am going to represent as D. I am going to represent as D, and this is also don't care. I am going to represent as D, and 1 1 D complement 0 0 and D complement and don't care, right? Now you need to form a Boolean expression. How can you do that? So for this, in order to like create an expression for the given K map, basically you can do. But if there are any kind of don't cares, what you can do, right? D means what here? Certain kind of variables. D is one kind of variable, and pi is what? Don't care. So in place of this one, you are going to get either 0 or 1. D and D bar are variables. One is a normal, any kind of min term, any kind of min term. At that situation, what you are going to do means, first step is, in step 1, you are going to place for all variables, you have to place all zeros. Wherever you are going to identify variables, simply place them zeros. Simply place them zeros. If you are going to place them zeros, what will happen? D is a variable 0 0 1 1 as usual. D bar is a variable 0, this is 0. D bar is a variable 0, and in place of pi you should not modify anything, and try to solve this expression. If you are going to solve this expression, you are going to get this is AB C 0 1 0 0, sorry, 0 1 0 1 1 1 1 0. Right? How we are going to get the expression here? You have to simplify it, right? So if you are going to take in place of this pi 1, what will happen? Is it minimized or it is maximized? Maximized. So you should not consider this don't pair terminology, right? Now if I consider this will, you are going to get a bar b. This is the first step you have to do, right? In the second step, you have to put in place of ones, put with pi symbol. Put with pi symbol. Pi symbol means what? Don't care. In place of variable d's, normal variables, you have to put with ones. In place of complements, put with zeros. Complements put with zero, right? Then you are going to get the table like this, right? This should be ABC 0 1 0 0 0 1 1 1 1 0. What is going to get to happen, ma? Try to observe. In place of ones, if you put zero, pi, this is pi, this is pi. In place of this, if you put 1 1 1, in place of d bars, if you put 0 0 0, and this should be pi as this, right? Now what is the output you are going to get? Can I combine these four? Yes. If I combine these four, what is the result you are going to get? You are going to get a bar, right? Next, in step 3, you have to exchange. In place of ones, you have to put with simply don't cares. In place of normal variables, you have to put with zeros. In place of complements, you have to put with ones. If you do like this, what is going to happen? ABC 0 1 0 0 0 1 1 0 1 1 1 0 1 1, right? Now try to fill the gap. So in place of ones, you have to place don't care. In place of these, you have to place zeros. In place of ones, you have to, sorry, in place of d bars, you have to place ones. So 1 1. In place of don't care, you have to place don't care, right? Now what is the resultant expression you are going to get? Can you able to combine the maximum of 4? Can you able to combine? No, it couldn't possible. Can I able to combine with these two? Yes, you can able to. Can I combine with these two? Is there any use? If I combine, you are going to get extra term. That's it. You cannot able to use, right? So what is the value you are going to get? I think A is not changing. So A C bar. So in step 4, you need to do, you need to write step 1 as this, and step 2 should be multiplied with normal variable, and step 3 should be multiplied with the complement variable. So your result will be like a bar b, a bar d, a bar as usual, a bar d, and a c bar d bar. This is what the final expression for this one, right? Meaning that when you are going to get any kind of variable entrant map as a kind of a mapping table, you have to follow this certain procedure in order to get your final output. If you are not going to follow, that will be a difficult procedure in order to get this one. Okay, right? So if you take this one, so there is a function called f of a comma b comma c, A comma B comma C, they are expressed in the form of sum of the products, where some of the products are like 3, 5, 6, 7. Min terms are 3, 5, 6, 7. They need to realized, meaning that it need to be realized by using variable entrant map. Then find P, Q, R and S. Find P, Q, R and S for the variable entrant map. They have given as A, B, P, S, R, Q. This is 0, this is 0, 1. Right? They have given the options also. P equal to 0, R equal to S equal to C, Q equal to 1, B as P equal to Q equal to 0, R equal to C, S equal to 1. Option C, P equal to 0, Q equal to R equal to C, S equal to 1. Option D, none of these. Meaning that what they have given here, they have given one expression. That expression they want to express in variable entrant map. Then, meaning that they have given 3 variable K map expression that they are trying to represent in the form of 2 variable entrant map. Right? In this 2 variable entrant map, can I able to include one more variable? Yes. Right? That is what. Right? What values I place, it is going to satisfy the expression. So for this, what you can do now? So try to take out the possible values. A, B, C are the possibilities, right? If I take A, B, C are the possibilities, what is the expression you are going to get? For example, 000, 001, 010, 011, 100, 101, 110, 111. I think everything is done, right? Everything is done, right? What is this F? They have given already. F means what? 3, 5, 6, 7. What is 3? 3, 5, 6 and 7. What about all the remaining zeros? For zeros, right? Meaning that this is actually their function. This is actually their function. They want to represent in the form of 2 variable entrant map. So for this, what you can do, you need to generalize it, right? If you are going to have 2 variables A and B, what are the possible values? 0, 0, 0, 1, 1, 0, 1, 1, 1, 0, 1, 1, right? What about the function F, new function F? What is the possibilities you are going to get? Right, observe. When you are going to get 0, 0 as input, you are going to get 0 as output. Meaning that irrespective of input, you are getting what? 0. You are getting irrespective of 0. When you are going to have the 0, 1 as input, you are going to get as C. When you are going to give inputs as 1, 0, you are going to get the output as again C. When you are going to give the inputs as 1, 1, irrespective of input, you are going to get the output as C. Sorry, it should be 1. It should be 1, right? That is what. So they are trying to compare it with so 0, 0 defines P, 0, 1 defines S, 1, 0 defines R, 1, 1 defines Q, right? So you can just check which one it is, right? So P is 0, S and R are C, Q is 1. So option A is the correct answer. Like this, you can able to solve an expression. Okay, na? Fine. So let's see some of the gate questions which are given based on the concept of K maps. Okay. So this is the gate question which was asked in the year 2014 on set 3 for 1 mark. Consider the following in term expression of F. Right? They have given canonical form like sum of 0, 2, 5, 7, 8, 10, 13, 15. 2, 7, 8 and 13 are do not care terms. Okay. The minimal sum of the product form of F is. So what you have to do? How many variables are there here? 4 variables. So you can able to take 4 variable map. Try to solve by your own. Meanwhile, I'll try to draw the expression like table PQRS. You can write in any manner. There is no problem. So these values like 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. Right? And these values you can able to write like basically you can write 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15, right? So with respect to these remembering points, I can able to define, right? 0, 2, 5, 7, 8, 10, 13, 15, right? So before that, you have to make sure these two also. 2, 7, 8, 13, right? First remember 2, 7, 8, 13. 2 is a do not care term, okay? And 7 is also a do not care term. 8 is also a do not care term, and 30 is also do not care term, meaning that if it is necessary, we can able to make it as 1. If it is unnecessary, we could not consider it. Okay. So I have indicated do not care terms, and in addition to that, you have to make sure that the given expression 0 they have given, so I made it as 1 because they have given it as sum of the products expression, and 2 I have to consider because it is do not care term already there, and 5 I have to make it as 1. 7 already don't care. 8 already do not care. 10 is 1. 13 is already don't care. 15 is 1. 15 is 1, right? Guys, now try to observe, right? This is this is my table, right? So when you are going to get this thing, you have to first combine maximum subcube. What is the maximum subcube possible here? 4. Why possible 4? In these do not care terms, I can make as 1. In this do not care term, I can make it as 1. So if I combine these 4, you are going to get one expression. What is the expression? So 0, 1 is changing, so Q is not changing. And if it comes here, S is not changing, so QS. QS. Okay. Now, what about this one and this one? Can I do like this? Can I do this combination? I hope while explaining the concept also I have given, right? This combination also done, right? So meaning that these 4 will combine as one because it's a cube. On cube corner all will get, right? You have to think that it's a kind of folded. Or the simple thing is what? You can write the numbers. What is this number? 4 zeros. What is this number? 1,000,000. Meaning that they are adjacent or not? Yes. Similarly, if you take this one, 0, 0, 1, 0, is it adjacent or not? Adjacent means what? There should be maximum 1 bit change. I can call it as adjacent, right? So, okay. Now, what is the value of this one? What is the value is changing? P is changing, but Q is not changing. That value is what? 0. So, Q bar. Q bar. And from this side, R is changing, but S is not changing. That is also 0. So, S bar. So, total if you combine, the answer is QS plus Q bar S bar. So, option B is the correct answer. Okay, now fine. Next one, minimum sum of the products for f of w comma x comma y comma z shown in Karnaugh map below. K map means what? Karnaugh map, right? So where Karnaugh is an author, so they have given some expression, some table K map, right? What is output this one? Right? What you can do simply, you can make sure to combine maximum subcube of size 2 power m, right? What is the maximum size of 2 power m? Maximum size it is possible from the given data, right? So can I combine these two? Guys, try to observe. I can combine these two, right? I can combine these two, right? But if you observe this one, Why you are missing this one? Which is what? Maximum 4 size subq. So this is actually main subq is prime implicant. It internally contains what? These two sub. Right? Can I call those two as a prime implicants? No. Prime implicants means what? It should not be subpart of other prime implicant. So I should not consider those two. So you have to get a subcube of size 4. Right? What is the value of these two? Combine. So 0 is not changing. So you are going to get z bar. Here I think x is not changing. So you are going to get x. What about this 1 1? Can I do this 1 1 combine? Or do I need to use don't care terms? Can I do it with don't care terms? Yes. Now what is the expression you are going to get? I think 0 is not changing on the x axis. So you are going to get x bar, and on the y axis z is not changing. That is also normal variable zx, right? Z bar x plus zx bar. Is there any answer is there? Z bar x plus zx bar. Yes, option B is the correct answer. Right? This is the way you can able to solve it, right? Is there any other terms you have to include? That you have to think, because none is also given. Now, in the Karnaugh map shown below, x denotes don't care term. What is the minimal form of the function represented by the Karnaugh map is? Right? You can able to tell. What you can do? Can I combine these four? Yes. Now, what you can do? Corners. Very good. That's important one, right? Corners you can do. This one, and this and this. So that maximum combining you are going to do, you are going to get less number of literals. So that is what, right? So for black, first try to tell the answer. For black, what is the answer? A bar, B bar. For green, what is not changing? 0 is not changing for B. So B bar. For on y axis, D bar. Okay. And there are two more terms are left. Right? What are those? This one and this one. How can we combine? Can I combine these two? If I combine two, how many variables we are going to get? 3 variables are going to get, because 2 power 1. Can I combine with maximum size of 4? Can I combine with maximum size of 4? If I size maximum size of 4, that is 2 power 2. 4 minus 2 is 2 terms you are going to get. So which is less than the previous thing. So what is the value you are going to get here? Very good. A bar, D bar. A bar, D bar, right? So try to tell like which one is matching. A bar, B bar, B bar, D bar, A bar, D bar. A bar, B bar, B bar, D bar, A bar, B bar, D bar. So obviously option C and option A are not there, not required. Right? They have given one extra variable A bar. Okay. Okay. So you have to think in such a way that it has to match with our answer. Right? So can we go with these two? Try to check. Okay. A bar, B bar is perfectly correct. B bar, D bar is perfectly correct. We need to check about the A bar, D bar. Right? So almost answer is D only. But we need to cross check with A bar, B bar, D bar. Right? So if I am going to combine these two or these two, can I combine these two? Yes or no? What will happen? 0 0 0 1. What is this value? 1 0 0 1. Right? One bit is changing. So as they are adjacent, so I can able to consider. Right? If I consider these two, what will happen? So obviously 2 power 1, you are going to get 3 literals. 3 literals. So 3 literals means what? You are going to get B bar D, obviously. Sorry. On x axis, you are going to get A bar B. On x axis, you are going to get complete 0 1. That is A bar B. On y axis, you are hmm?
0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0
right? On x-axis, you have to take these two combination, right? 1 minute. This and this, right? So if you are taking this and this, on x-axis, you have to take only 0, 1. 0, 1 means what? A bar B. On y-axis, you have to combine 0, 0 and 1, 0. So you are going to get what? D bar. D bar. Right? A bar B, D bar. So answer is now what? Option B, not option C. Option D. Okay, B bar is there. So option B is also invalid. So finally you can take it as option D only. So you have to go through the options also multiple times. Otherwise it may lead to wrong answers. Right? Next one. Given the following Karnaugh map, which of the following represents the minimal sum of the products of the form of the map? What you can do, again you need to combine all ones with don't case. What you can do? Maximum 4, maximum 8 is not possible always. Maximum 4 is possible. Can I combine these 4? Yes or no? Can I combine these 4? What is the answer for this one? Y bar Z. Y bar Z. And can I combine these two? Can I combine these two? Yes. If I combine with above also, that is equal to 6. It is invalid. So I have to go with only 2 powers. Okay. So what is the value of this one? Y, and it should be x. Is there any another requirement is there? No. Yx plus y bar z. Yx plus y bar z. So option A is the correct answer. Okay. Where if you are going to include this, if it is going to include, which is going to be extra redundant term, and that may not also be in the answer. Okay. Now try to solve which of the following can be a prime implicant of the function f of a comma b comma c. Right? They are given the variables available for the function f of a comma b comma c. Which of the following can be a prime implicant? Right? If I would like to say that there is a prime implicant, it has to have only the respective data. Right? Here, how many prime implicants are there? 2 prime implicants are there. But what they are asking? A single prime implicant. So option A is incorrect. Can be a prime implicant. Option B is also incorrect because it contains 2 prime implicants. Option C also incorrect because it contains 2 prime implicants. Option D is the correct answer. In other terminology, if you would like to see A, B, C, I think they okay, 0, 1, 0, 0, 0, 1, 1, 1, 0, 1, 1, 0. To get AB, what you have to do? You have to combine at least 2, right? 3 variable kabatti, you have to combine 1. You have to combine 2 power 1 cells. 2 power 1 cells means A we need to include, that means one side you have to conclude, B has to be changed, C has to be changed, right? So can I say that uh, B should be changed, this should be 1, 1, 0. So I think this is 1. This is for what? AB. Am I right? If I try to take this as what? AB, because A this one, and from this like not changing is B, so I got AB. What about C? What about C? C means what? C means all ones. If you want to have, try to observe, if you want to have one literal as output, what is the length of the subcube for 3 variable? 2 square. Am I right or not? 4 are the sorry, 3 are the variables, 3 are the variables, and 2 square, if you are going to do 3 minus 2 is 1 literal. So the subcube size should be 4. The subcube size should be 4, right? What is that subcube size? Last 4, last 4 or not? Assume that this is k, this is k, this is k. What is the value of the sum of the k? C or not, right? Now observe the meaning. If I would like to say a prime implicant, this AB should not be part of C. AB should not be part of C, right? If it is not part of the C, then I can call it as a prime implicant. But if you observe, AB is now not a prime implicant. Am I right or not? AB is part of C, that's why I am not going to call it as a prime implicant. So, based upon this reason, I can cancel A, B as well as C. What is the meaning of this one? AB combination is a part of a C. When I say that AB is a part of a C, this is not a prime implicant. If they want to be prime implicant, those should not be complete part. Right? Based on that reason, I will say that AB is a prime implicant. Okay, fine. Take out the another question. What is the minimum number of 2 input NOR gates required to implement a 4 variable function expressed in sum of minterms form for this one? Right? So meaning that they have given one 4 variable K map, right? I think X, Y, I think any other variables you can take, any other variables, right? So you know 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15, right? What are the values? For 0 you have to consider as 1, for 2, 5, 7, 8, 10, 13 and 15, right? Assume that all the inputs and their complements are available, right? So what is the conclusion you can be able to do? Can I able to combine these 4? Can I able to combine these 4? Yes. How many terms you are getting? 2 terms, right? What are those? Right? So the terms are like for middle one, for AX, what is the value? Y, B, very good. For another one, Y bar, Y bar, B bar, Y bar and B bar, right? This is my expression, right? This expression they need to implement in the form of NOR gates. This expression they need to implement in the form of NOR gate, right? What is this expression? Okay, XNOR. It is XNOR actually, but the thing is they are asking us to implement with the help of 2 input NOR gates, meaning that purely NOR gates you have to use, right? So if you would like to use purely NOR gates for XNOR, what you can do? Can you add one more NOR gate for XNOR? For NOR gate, you are going to add one more NOR gate. What will happen? Let's see. This is what XNOR. For XNOR, if you add one more R, you are going to get normal R. Normal, right? So you have to, right? So try to observe. It is in some of the products. It is in some of the products. They are asking the NAR. So NAR means what we can do. So you can able to implement it with the help of AND OR gates. Can we able to do it with the OR AND gates? If you would like to do, try to convert it into product of the sums. How can you do that? See, what are the values? These values, sum of the product values. What are the product of some values? 1, 3, 4, 6, 9, 11, 12, 14. 14. Try to combine, right? Those values are like these zeros: 0, 0, 0, 0, 0, 0. How can we combine? These 4 you can combine. These 4 you can combine. If you combine, what is the value of this one? Only y is not changing. So y means what? Y bar. This will be in the product of the sums. Y bar. And what about these two combining? 0 0 1 0, meaning that not b bar, it is b. Y bar plus b is one expression. Am I right or not? Yes. So this is y bar means what ma? 1. 0 means what? B only. B only. Right? What about this terminology above? This what is changing here? 1 is not changing. When 1 is not changing, this should be B bar. What about these two? Y is not changing. Y bar plus B bar. Y bar or Y? Y plus B bar. Y plus B bar, right? Now try to implement the expression Y plus B bar into Y bar plus B, right? So all the complements and their inputs are available, meaning that Y is there, B is there, B complement is there, Y bar is also there. Y bar is also there, right? It is in the form of what? Product of sums. Product of the sums, right? So what you can do here, simply you can write one OR gate. Here also you can write one more OR gate. Finally you can able to combine. You can able to combine, right? For this what you can do? NOR, and I can make this as one more NOR. So total how many? 3. So total 2 input NOR gates are required in order to solve this expression. Is it okay? What I did ma here, they haven't given directly. So I tried to convert some of the products into product of the sums. Then I tried to take out all the zeros. Then I made implementation of OR and gate. For that outputs I made complement. The input I made it as complement. Finally I converted into NOR gate. So total how many NOR gates are required? 3 NOR gates are required. Next one. See, this is a 2 marks question number. Next one also 2 marks question. Consider the minterm list of Boolean functions. 4 variables are there. Their minterms they have given. Their don't cares are given. And M denotes minterm. D denotes don't care term. The number of essential prime implicants of the function f is. So what you have to do? When the question is like this, you have to compulsory follow the procedure. Otherwise, you may get misleading answers. That too, the answers are not given. This should be like a kind of entering the numbering value. So what you can do? I think PQ RS 10. So these values are like 0 1 2 3 4 5 6 7 8 9 11 10 and 12 13 14 and 15, right? What are the values they have given? 0 given, 2 5 7 9 11, and don't cares are 3 8 10 12 14, 10 12 14, right? So now in this particular map, 4 variable map, what are the essential prime implicants? That is what they are asking. What you can do more simply, essential prime implicants. Can I take these two? Can I take these two? Because without any thing, compulsory these has to be covered. So compulsory I will take the these two, and I will take these corners. These corners. Can I consider this also? Yes. So the answer is around 3. Not around 3, it's 3. Okay. So to make it clear for you, what you have to do? You have to go through the procedure. That's the simple thing where you will get the correct answer. Even if it is going to take time also, there is no problem. Try to go through the procedure. Right? As per my understanding here, the answer is 3. The answer is 3. Right? So because even if I am going to include the corners, these has to be covered by whom? It has to be covered by some other, right? That's why I have taken this one. So even these 4 has covered, it has to be covered by someone. That it has to be compulsory 3 essential prime implicants. Okay. Now, is there any prime implicants are there? How many prime implicants are there? Okay, essential prime implicants are 3. What about prime implicants? Prime implicants. Can I call this also one more prime implicant? Yes? No, because it's a part of prime implicant. Essential prime implicant also prime implicant. So I should not call this as a prime implicant. Can I take this as a prime implicant? Yes or no? I can take this also prime implicant. Is there any other thing is there? Can I take 12 and 10? 12 and 10. No, this is subpart. I mean 12 means what? Not 12. 2 and 10. 2 and 10 is subpart of the actual part. So this is not right. But if we take 3 and 2, definitely this is a prime implicant. Is there any other things are there? Huh? 12, 12, 14. What is the necessary for taking the 12 and 14? Both are don't case, right? Is there any use of it? There is no use. It should not take. Any other doubts? So total prime implicants are 4. So if you want, you can cross check later part. Okay. Right. So next one, the literal count of a Boolean function, Boolean expression is sum of the number of times each literal appears in the expression. Right? For example, the literal count of xy plus x z bar is 4. I hope you know the meaning of literal count. While expressing the Boolean expression, I have clearly mentioned. Duplicate also you have to consider. So that is what they have done. Then xy plus xz bar total literal count is what? 4. Meaning that x and x also considered as individual. What are the minimum possible literal counts of the product of sum and sum of the product representations respectively of the function given by the following Karnaugh map? Hence, here x denotes don't care. Right? So meaning that what they are trying to ask here, you need to consider all the ones for some of the products and you need to get an expression. Try to count total number of literals. I am assuming it as x. And for product of the sums, you have to get an expression and try to take out all literals. I am assuming it as y. What is the answer you have to define? X comma y. So I think you can do it for the coming class. Can you do it? Yes. So I think the answer will be 9 comma 10. So I am giving the answer by myself. So you can just cross check with the answer. Okay. So what you have to do simple. You have to first count all ones along with don't cares for getting the sum of the product expression. For product of the expression, you have to count zeros with don't cares. Okay, fine. Next one, which function does not implement the Karnaugh map given below? Meaning that they have given one Karnaugh map. You need to answer which of the following function is not possible, right? But they haven't given any sum of the products or product of the sums. That you have to understand, right? So you have to take the choice by yourself. So you have to take by first I am assuming that sum of the products. If any answer is not there, you have to assume that product of the sums, right? So I am going to assume that sum of the products, right? If I am assuming that sum of the products, what is the subcubes are possible? Can I make this subcube? Yes. Can I make this horizontal subcube as one subcube? Can I make this as one subcube? Yes. So three prime implicants are there. Can I say? Is there any prime implicants are possible for some of the products? No. Only three prime implicants are there. Okay. Now Now, after solving this expression, which of the following may not be get? Right? Try to solve. So, assume that this is A and B and C. For A, what is the expression you are going to get? For A, you are going to get xy, xy. For B, you are going to get, for B, you are going to get w bar z. Guys, but if you think here, if you think here, do we need to consider B? B is a redundant term or not? Because this one is already covering, this one is already covering. Then why we need to take one more subterm where the remaining all are don't cares? There is no need. There is no value, right? So I can remove the B sub q. So I can remove the B sub q. What about C? C has to be compulsory included. So if I include it, you are going to get here y, y and w, xy plus yw. Xy plus yw is B. B is possible, right? But not implemented, right? So can I go with the? Can I go with like? Is these two are same or not? If I take the common y, again you are going to get w plus x also. This is also correct. What about this expression? Can I directly make it as option? No. You have to take the product of the sums also. Right? What are the product of the sums? 0, 0 along with don't cares. I forgot it here, don't cares. I think this is don't cares, right? Right, now try to observe. Can I consider this one and this one? This black and black will carry it to, I think you are going to do for how many? 8 combination. When you are going to do 8 combination, you are going to get 2 literals. Right? So you are going to get y or y bar. It's y. In product of sums, 0 means y plus y plus what are the values? So y. Ah, okay, very good, very good. So meaning that it is powers of 3, right? So 2 cube is 8. So 5 minus 3 is 1. So we are going to get only one letter. Y. Okay, good. Y. And is there any other possibility? Is there any possibility? If I am going to take any one, like if I take this and this, that will be a prime implicant. But can I combine these four? Can I combine these four? Because it is not a prime implicant. If I combine these four, what you are going to get? You are going to get oh, okay, x bar. Sorry, x. This is what 0 0 is not changing, right? So x plus double, x plus double. Okay, so x plus w is 1, another one is y, another one is y. Is there any other answers are there? So I think you got w plus x, w plus x, and can we able to get this expression? I think all are covered, right? All are covered. Is there anywhere we haven't covered anything? Huh? No, we should not consider the remaining things because if I see observe, if I try to take 0 0 and this 0 0, what will happen? It's again a subpart of the actual part. It's again a subpart of the actual part, so you should not consider. That's for sure, right? Uh, if you take any sum, any subpart, it will be part of it. It will be part of it. Or else, if you take these two, if you take these two, what is the expression you are going to get? W plus, sorry, x x plus y bar, x plus y bar. and on the top you are going to get W, x plus y bar into W, right? So the option C is the correct answer, right? So option C couldn't possible as per this explanation, right? So try to cross check once again. If any ambiguity, let me know. Okay, right? Okay. So this is for today's class.